Hello everyone. Today, I'll be making the unusual oxidizing agent Tetrachus pyridine silver 2-persulfate, which is one of the few compounds that feature the rare and extremely unstable 2+ oxidation state of silver, and is so obscure that nobody else on YouTube has made it before until now. To make the Tetrachus pyridine silver 2-persulfate, which I'll shorten to TPSP from now on, I first add to 40 ml of distilled water 4 ml of suspiciously yellow pyridine, and 1 gram of the silver nitrate I made in a previous video, and wait for everything to dissolve. This forms the Tetrachus pyridine silver 1+ complex. It's extremely important to use distilled water for this, as chloride or fluoride contamination would cause their insoluble silver salts to precipitate out, which would ruin everything. Now, I make a second solution of 10.5 grams of potassium persulfate and 600 ml of distilled water. After everything dissolves, I slowly drip in my first solution, and instantly everything turns cloudy. When that happened, I thought that surely my distilled water had some chloride in it, and that it had ruined everything, but the solution soon turned yellow and then orange. What's happening right now is that the silver 1+ in the Tetrachus pyridine silver 1+ complex is being oxidized to silver 2+ by the potassium persulfate. Normally, this silver would instantly find something else to oxidize to return to the 1+ state, but it's stabilized by the pyridine ligands and precipitates out as an insoluble persulfate salt. I let the precipitate settle to the bottom and decant off the top solution. Now, I first vacuum filtered off around half of my TPSP as I was concerned the filter paper I used would react with such a strong oxidizer, and first decided to make sure that the TPSP's oxidizing properties were maintained after contact with cellulose by running a few experiments. When TPSP was added to sodium bromide solution and stirred, the solution visibly darkened, likely from bromine formation. However, when TPSP was suspended in water and sodium bromide was added to it, the solution turned brown and a precipitate was formed. I suspect that suspending TPSP in water caused the pyridine ligands to fall off, causing silver bromides to form and rapidly decompose in sunlight. If anyone else has an explanation for this, please comment down below. TPSP turns potassium iodine solution yellow, likely from iodine formation. When TPSP was added to hydrochloric acid, it turns white and yellows very slightly. This is due to the pyridine reacting with the hydrochloric acid to form pyridine hydrochloride and leaving, and the bare silver 2+ to oxidize the chloride to chlorine and form the insoluble silver chloride. Now, seeing that the TPSP retained its oxidizing properties despite contact with the cellulose from the filter paper, I filtered everything else and proceeded to use up all of it in subsequent experiments. When TPSP was added to the concentrated ammonia solution I made last video, some gas was generated, which should have been nitrogen from the oxidation of the ammonia. When TPSP was added to azeotropic nitric acid, it turned black but lightened up over time, though it was reported to dissolve in nitric acid without oxidizing, so it may require fuming nitric acid instead of azeotropic. I then added some methanol, and somehow that turned everything white, which was interesting. Adding TPSP to methanol seems to have no immediate effect. When TPSP was added to concentrated sodium hydroxide, the black silver 1,3 oxide or tetrasulfur tetroxide is formed, which can be seen decomposing in solution with oxygen evolution. Lastly, I tried to oxidize manganese dioxide with TPSP to permanganate. After stirring for a while, the suspension becomes vaguely purple, but dilution in water makes the purple color much more apparent, and it even intensifies, perhaps from the silver 2+ oxidizing the manganese dioxide much faster after its pyridine ligands fall off. Now, I add some sodium thiosulfate to reduce the permanganate, and you really can see a difference now that all of it has been reduced to manganese dioxide. This is what the TPSP looked like after being left outside for 4 days. As you can see, the part exposed to air, moisture, and light is significantly darker than the part that was only exposed to light.